Welcome to the math record. For the second part of the ICTM Regional 2018 Division Double A Geometry, I'll be answering questions 10 and 11. Okay, let's start with number 10. So we have this circle. So circle, and we have two lines. So something like this, and then something like this. Okay, and we have CE is length 2, and DE is length 6, and EB is length 3. So in the question, they're asking for the area of this circle is k pi. Determine the value of k. So we need to find the area. So first, let's find this side length. And this is just to describe angles and lines. So the product of the segments are the same. So 2 times 6 is 12. 12 divided by 3 is 4. So that tells us that this length is 4. And now what we're going to do is that we're going to think that we're going to have to make a triangle. So, oops, right here and right here. So our triangle is right here. So if we have a circle that goes around this triangle, it's called a circumcircle. And a circumcircle also has a radius called a circumradius. And a circumradius is calculated by multiplying its side lengths together. So multiplying its three side lengths together divided by 4 times the area of that triangle. So we need to first find the side lengths. So 3 squared plus 6 squared using the Pythagorean theorem, because this is a perpendicular, because that's what they gave us. So 3 squared is 9, 6 squared is 36, so 9 plus 36 is 45. Square root 45 is 3 square root 5. Okay, and then this triangle, which is also another perpendicular, we need to get the side length. This is 4 squared plus 6 squared, so that's 16 and 36. And that makes 52. And 52 is divisible by 4, so that's 2 square root 13. Okay, so now we have our three side lengths. So we have our radius is going to be equal to 4 plus 3, which is 7, times 3 squared root 5, times 2 squared root 13, divided by 4 times the area. And the area of this triangle is just base times height, so 7 times 6 times 1/2. Okay, so then we could cancel out our 7s. The 6 and the 1/2 makes a 3. Cancel it with this 3. And this 2 cancel with this 4 to make with the 2 on the bottom. So our radius is actually square root 5 times 13. Because square root 5 times square root 13 just multiplies inside the radical. And 2 on the bottom. And our radius is calculated, but our area of our circle is calculated by pi radius squared. And that's equal to our k pi. So our k is equal to r squared, so we just need to square this. So square root 5 times 13 squared is just 5 times 13, which is 65. And then 2 squared is 4. So our value for k is 65 over 4. Okay, and that's the answer for number 10. Okay, number 11. A square sits on the top of a regular hexagonal tile so that the diagonals of the square exactly overlaps one of the longest diagonals of the hexagon. So like this. The area of the hexagon that shows from under the square is k%. Determine the value of k. So they're asking to find the the proportion of basically the shaded area over the entire area of the hexagon. So let's kind of draw a picture. So we need a hexagon. That looks fine. And now we need a square. And move it a bit. Okay, it's a little bit tilted. A little bit more. That looks fine. It's good enough. And we have a center. So, and then these are 4 shaded areas. So we all know that the areas of these 4 shaded are logically probably going to be the same area. So let's kind of like split this up into sections, which we could just solve individually. So I'm going to cut into fourths. Okay, it's supposed to cut evenly, but it's not really drawn to scale. Okay, so that tells us if we want to get the area of, let's say, okay, write this. So if we want to get the area of this, so to get the area of this, we need to somehow get the area of this entire hexagon subtracted by this area that's inside. So we need to take away these areas of these triangles, subtract the area of our hexagon by the area of this kind of circle, the amount of the square that's in the hexagon, and then we'll get these four areas. So that tells us that we need to get the area of this section that's overlapping between the square and the hexagon. So we need to get the area of this small triangle. So that's what we're going to do first. So we're going to get the area of the small triangle, subtract it by the area of this. So we're going to have an area of this triangle, subtracted by the area of this small triangle, so we could get the area of this section, multiply by 4, so we could get all these areas. And then we have a hexagon subtracted by that area to get those shaded. So that's going to be our game plan. So usually I like to think about what I need to do before I start doing anything. So, okay. So let's label some of our side links. So usually if questions like these, if it's going to be a general case with proportions, the variables usually cancel out themselves. So I like to use the smallest side length. So I would just say this is a hexagon of length 1. So because it's supposed to apply for every single case. So you should use any case and all the proportions to stay the same. So logically it should. So then we could just use whatever we want. So if I say this is length 1 and this is a square, right? And this is a hexagon which is made of equilateral triangles, that means this is length 1, this is length 1, this is length 1, and this is length 1, right? But first, let's think about what's the length from here to here. So if we draw another equilateral triangle, this is a 60, 60, 60, right? And this is 30 degrees. And we know that this is equilateral, so this is length 1 also. So opposite of the 60 degrees is square root 3 over 2. And that's just the 30, 60, 90 triangle, if you know the special right triangles. So that gives us that this length is square root 3 over 2. And if this entire length is length 1, then this section is 1 minus square root 3 over 2. Okay? Now, how do we get the area of this small triangle? Well, basically, I know that these two lengths are the same. And the reason is because if you logically think about it, this length and this length should be exactly the same. So that's a 45 and that's a 45 degree. And this is a this is a square, so that's a right triangle. And if you cut it right in half, then this right triangle divides by 2 to get 45. And this part becomes a 90. So it's kind of hard to see, but basically we have a triangle like this, and this is 90, and this was a 45, 45. So I'm talking about this triangle. And then we basically cut it in half, make a 90. So if we cut this 90 in half, a 90 divided by 2 is 45. So that's a 45, 45 triangle. So that tells us that basically this height is equal to this side length. So we know that this side length is also 1 minus square root 3 over 2. So the area is 1 minus square root 3 over 2 times 1 over square root 3 over 2, which is just 1 minus square root 3 over 2 squared. And then multiply by a half to get the area of this. Now, what's the area of the big triangle? Well, this is length 1 and this is length 1, so 1 times 1 is 1, divided by 2 is 1 half. So that's the area of our big triangle. And now to get the area of this section, we just need to subtract the 2. So we have 1 half minus 1 half, 1 minus square root 3 over 2x squared. So there's no s times squared, okay? So that's the area of this. And now we just need to multiply by 4 so we could get all 4 areas, right? Because there's 4 of them. So we multiply by 4. 4 times 1 half is 2. 4 times this 1 half is 2. And then 1 minus square root 3 over 2 squared. Okay, so that's the area of this section of the section of that's overlapping between the square and the hexagon. And now we need to find the area of a hexagon, which is really simple. The formula is just 3x squared square root 3 over 4. I mean 2. And the reason I know is because the area of an equilateral triangle is x squared square root 3 over 4. And since a hexagon has 6 equilateral triangles, you just multiply by 6. So that cancels out with the 2, that's a 2, and that's a 3. So x squared squared 3 over 2. And that's the area of a regular hexagon. And x is just going to be the side length. Since our side length is 1, this is just going to be equal to 3 square root 3 over 2. Okay, so we know that. Oops. So we know it's the area of the hexagon is 3 square root 3 over 2. And now to get the area that's outside, right, we just have the area of the entire hexagon minus the area that's overlapping. So that is 3 square root 3. I'll just write a little bit smaller. So 3 square root 3 over 2 minus this area, which is 2 minus 2 square 1 minus square root 3 over 2 squared, right? And then we divide it by, so that's the area of the shaded, right? Of all four shaded. And then we need to divide by our area of our hexagon to get our value for k. So that is also 3 square root 3 over 2. So since we had to use our calculator to find to the nearest tenth, just plug this on your calculator without simplifying. So then we have 3 square root 3 over 2 minus 2 minus 2 times 1 minus square root 3 over 2 squared divided by 3 square root 3 over 2. And you should get and then you should get a value of 0.244. And since this is in percentage, you got to move the decimal place 2 places, so you have 24.4. And that is your answer for number 11. Okay, so you just need to take things step by step, and then you should get everything right. Well, that concludes the second part. I'll see you at the third part for this contest.